So guys, section 2.2 is about solving a system of equations without graphing them. And I would think you probably have learned these before. One's called substitution, the other one's called elimination methods. But if you don't recall, this would be a good refresher. So take a look over here in this box. This is kind of helpful though as far as when to use what. So basically for substitution, you want to say to yourself, hey, do I already have a letter by itself? So in number one, if you take a look at this bottom equation, the letter x is all by itself. Doesn't have to be y since we're not graphing. So right slope intercept form would be to have y by itself, and we're not doing graphing. So that guy's already got the x all by itself. And over here on number two, this y right here would be really easy to get by itself. And actually either letter for that bottom equation would be fairly easy to get a letter by itself. So that kind of tells you that these two equations might be a good way to go with substitution. So since the first equation already has a letter by itself, we're saying x equals this stuff. So if that just said a number, if I said x equals 4, I hope it would make sense we plug the 4 in for the x. If it said x equals -6, you'd plug the -6 in for x. So x equals that stuff. Well, I'm going to put all that stuff right there where the x is. So we always want to plug it into the other equation. All right, so here we go. Instead of the x on the first equation, I'm going to write 2y minus 1 because that's what x equals. Parentheses would be optional in this case, but if there had been a number right here in front, then we would have to do the distributive property. So I like putting it anyway. And the rest of that equation went plus 2y equals 11. So the goal is, the reason for it is, if you look at this new equation we have, there's a y, there's no more x. So we're capable of solving equations with one letter, not equations with two letters, down to one. So distributive property here, kind of like multiplying by a 1 out in front, wouldn't change this guy at all. And you could have skipped this step. Simplify what we can simplify. I got a 2y and a 2y on the same side. I'm going to add those guys up. How do we get the -1 to the other side? Going to add them. Now how do we get rid of the 4 we divide? So once you get to that point, it's just regular old equation solving. So now keep in mind, if we had graphed these, you're looking for a set of coordinates, plural coordinates. So I know what the y is, and now I got to figure out what the x is. Well, if you know what y equals, then all we have to do is plug him back in to either one of the equations because they cross in the same spot. So the bottom equation would have been the easier one to do. Let's go a different color here. So that bottom equation says that x equals 2 times whatever y is, but we just figured out it's 3. Subtract 1. So, if you wanted to be better safe than sorry, you could literally pick up a calculator and do this. It comes out to equal 5. Okay, now one thing we'd like to see you do, even though we didn't graph, it's understood that that's what we're finding. We're finding a set of coordinates. Make sure you're writing the x first. Make sure you're writing the y second. And we got it. Okay, number 2 is going to require a little extra work. So again, you could take either equation, get a letter by itself. I'm just going to work off the top one. Doesn't matter. So I want a letter by itself. It would be easiest to get that y by itself. And I could do that by subtracting the 3x to the other side. Wouldn't need the plus 0. Wouldn't hurt if you used it. Okay, but now same thing. Here's the point. I know it doesn't exactly say y is a number. It says y equals -3x. But that -3x is going to go right there where the y was. So that bottom equation said x plus whatever y was. We just determined it's -3x equals -2. And then we're just going to solve. Combine those x's, +1 and -3 makes -2. Divide both sides by -2. And I got 1. So that's one of the answers. Again, plug it back in. Now, you can plug it back into any equation. You could plug it back into this original equation. You could plug it back into that original equation. Or the easiest one would be the one that you got the letter by itself. They all represent the same equation. So I'm going to plug that 1 in. to the guy that we changed that said negative 3x. Well, I found out what x is, so I'm going to plug a 1 in, and then I just do the math. And we got it. But again, understood to be coordinates that we're finding. That's what x stands for, that's what y stands for. So we're going to write it in coordinate form for an answer. And there you go. That's a refresher on the substitution method. So let's drop down here and at least get one of the elimination problems in. So over here in this box, when is it appropriate to use the elimination method? When one of the variables cancels out. So rather than try to explain that, let me just show it to you. It'd be easier. So on number 3, somewhere along the way, somebody discovered this little deal. And they figured out that if you were just to go ahead and add straight down or combine straight down, turns out to be legal, because if you think about it, you're doing the same thing to both sides of the equation. And conveniently, if I add the x's, 6x and negative 4x would make 2x. But what would happen to the y's? Negative 5y and positive 5y would cancel, and they're gone. Add the numbers on the end, same thing, negative 18 plus 8 would be negative 10. Not sure what I was about to write. Let me rewrite that. But again, the key is where'd the y go? He's gone. And we can solve equations with one letter. I'm going to divide both sides by 2, and I got it. Now, the only thing that makes this, it starts off a little easier if you ask me. The thing that makes this one a little tougher is part 2, where you have to plug this negative 5 back in because you don't have an equation that has a letter by itself. So you can use either equation. I'm going to use the bottom one for no particular reason. They will give you the same answer. So it said negative 4x, and we found out that x was negative 5, so we'll plug him in. It said plus 5y. I hope you could still read up there. I scribbled it out a little bit. Equals 8. And then we just solve like normal. Multiply those two guys together. How do I get the 20 to the other side? I would subtract. And I get rid of the 5 by dividing. So what's nice, that's a 5. What's nice about this is if you had tried to graph this one, it wouldn't have made much sense because your lines were crossed in between grid marks, and that would have been tough to tell what the answer is. So for these guys, you can get decimals, you can get fractions for answers, and you didn't have to graph to do it. So really, who cares? Coordinate form, negative 5 was x. Negative 12/5. Just make sure your fraction is reduced, which in this case 12/5 is, and you got it. Okay, number 4. Let's see here. I think I have just enough time. Well, I'll tell you what. Let me look down here. 4 problems to do. Yeah, I can get 4 problems in. I'm going to save this guy for part 2 video, which I'm going to have to run regardless. So if you need a little more refresher on the elimination method, please stay tuned for part 2 video. And also take a look down here. It does say solve using either algebraic method. So the ones at the bottom might not be a bad group to check out because you are going to be asked on a quiz or a test to choose. And if you can choose the right way, the better way, you're more likely to get them right. All right, guys, thanks for watching part 1.